Good morning, good afternoon, and good evening, wherever you are watching from. And I welcome you to day 10 of our 12 days Geospatial Python Bootcamp. And today, in particular, we'll be looking at, we have been doing rasters, I think for some days now. And today, the last time we were supposed to do mosaicing, and time did not permit us. So today we will do the mosaicing, and we'll continue to see how we can perform spectral indices with Python. So stuff like NDWI, NDVI, and the other ones that there is. Sorry. So let us get quickly and straightforward into it. You see, today I opened VS Code straight away. We are not using any PowerPoint today. We don't need it. So let us get right into Visual Studio Code and start the business for the day. Okay, so the first thing to do is to start with a mosaicing. And inside my day 10 folder here, you should see that it's not empty. I have a folder here called LC09. This one is just some Landsat data sets, Landsat 9 data sets that I acquired. If I expand it, you see all the bands in there. Let me just open it in containing folder. Okay, so these are all the stuff. If you download a Landsat image, you should have something like this folder structure that looks like this. So all the bands are in there. I intentionally did not touch any of them. I did not even rename them. Only the folder name that I renamed to LC09. But all the bands are in there. Today we will learn how to use them. Because we are doing indices, we will need those bands. Okay. So I believe you have your own image. If you don't have it, the last time I showed how to download it, you can download one and follow along. Okay, I think the last time I turned off my autosave, let me bring it back. Okay. So let's scroll down to the mosaicing part. And what we'll do is that we'll come into QGIS, and then we'll quickly, because we don't have any two files that we have to mosaic, we'll quickly create some. We can do that in code. I've shown you how to do this clipping in previous videos. We can type the code here again, but I will not do that. What I'll do is to open QGIS and just crop two things out, and then we see how that one goes. Okay, so let me come into my day 10 folder. It's not recognizing it. We don't have day 10. And I have it here in code. That's the day 10 folder. Oh, okay. It's up here. It's up here because it's 10. So let me just bring the first band, this one. And then we don't have any shapefile. So quickly, let me come to VS Code. Let me create a folder for shapefiles like I always do. So I'll call it SHPS. You can choose to call it any name. And then here, what I'll do is to create a new shapefile. So I'm speaking over these processes because that is not really the agenda for the day. I suppose you know how to create shapefiles in QGIS, but if you don't, you just right-click on the folder that you want to create that particular shapefile in. Among the pop-ups, just choose New, and then you should see save file there. The file name at the top there, usually they will give it a name like newlayer.shp. So just delete the new layer just after the last separator, whether it is / or backslash, and before the .shp. I'll call this one ROI_1, signifying the first region of interest. The geometry type should be polygon, and the CRS. The CRS for the Landsat image is WGS 1984 UTM zone 30. So that is what I'll select for the shapefile we'll be using to crop out two places and mosaic them. So just make sure that you select whichever coordinate system your raster is in, you just select that one also. So I'll create a new shapefile, this one called ROI2. Don't forget to change your coordinate system to the raster's coordinate system. Then we create them. So I can drag them onto our map layers. And what I'll do is to enable editing for each of them. So I right click and then toggle editing. But let's do it for one before we do it for two. This is the Lake Bosomchin, the place that I've been using almost throughout. So what I'll do is to create a shapefile that covers up to about half of the lake and another one that covers the other half. Let's see. So I'll come up here. When you are done, you just right click and you press OK because you're not filling in anything. I save it. I toggle off the editing, come to the second one. I can also toggle the editing with the pencil at the top here. Or I'll right click like I did and toggle editing. And then I'll come back, but I'll make sure that this particular, the second shapefile slightly overlaps with the first. And the size should not really necessarily be the same. So we see how that one to go. So I can click on the pencil, it will ask me, and then I'll save it before I close editing. So now we have these two shapefiles. We can go ahead and clip with Python, but today's lesson again is not on clipping. We have done that. So let me quickly do that with QGIS. So I'll go and then say clip raster, and then clip raster by mask layer. So the raster that I want to click is this one. And then let me choose the ROI one. These ones are all optional. What I want to do is not to save to a temporary file, but to save to a file. And then the 10. Let me create a new folder here. And let me call it IMGS, maybe images. And then in there, what I'll do is to say first. I'm out of options. So first.tif, first.tif, save. Okay. And then I can run. So it has stopped that one for me. And then I can come back here, change it to ROI2, and then the name to second, and then run that one too. Okay, so what I should have if I check off this ROIs, in fact, if I delete everything apart from the two that we cropped, I should see two files like this, but these are separate files. If I check off one, you see that they are separate files. So the goal is to create a mosaic that will combine these two files into one. Okay. Let me remove them from here, and then let's go to VS Code and see how that one will come in. Okay, so I'll collapse this side. And then bring up code. But let me select a kernel so that my code will be recognized. Okay, so what I want to do is to say maybe images. Okay, we need some import. So import Rasterio as real. I think we need OS. So let me just import OS. And what do we need again? For the mosaicing, I think that should be, oh, yeah. No, we need geopandas. No, we are not clipping, so we don't need geopandas. But what we also need to do is to say from Rasterio dot I think it's merge import and then import merge like this. So we import that one too from Rasterio. Let's run this cell. Everything is done. So the next one that we do, where the images are, so images directory, that should be dot slash, we named it imgs. Let me confirm that it is true. Yes. And then also I can say files equal to os.list directory. So all the files that are in there, I just want to get all of them so that we can merge them at once, not to read them one after the other. So os.list directory, and I pass in the images directory. What this thing will do is that to get me the name of all the files in there. So if I run it, you see that I have first and second. Yes, it's good that I did run this thing. So we have to get rid of these two files. Those are not the files that we are interested in to read. So what I can do is, like I did the last time, I'll put this in a list and say item for item in, then I put this in again. I say if item dot ends with, and then I will make sure it ends with dot save, like that. So in that case, when I run it again, I only have those two files that we are interested in. Okay. So now what do we do next? What we can do, should I bring it to a new cell or it should be in there? Okay, let it be in here. So perform mosaic. We can say SRC files. That should be equal to, now say real.open, and then we will say file or whatever name for file in, how do you call it, files. Okay, so what is this line also doing? Let me just print out SRC, then I'll explain what this one too is doing. I think the syntax is getting a little bit advanced, but it shouldn't be so confusing. Says what? Okay, there's no such file or directory. I should have known that. Forgive me. What I can do here is to say that delete the file completely. So Rasterio real.open, and then I have to combine this path with the file name. So I will say os.path.join, and then in here I can pass in images directory and then file. Maybe should I put it on new lines? It shouldn't confuse you. All this long code here is just to open a file. Open every single file in files. So this part here should run for every single file in our files files list, which I printed out for you to see. That's just the first.tif and second.tif that we created in QGIS not long ago. But what makes this one long is that we are trying to use the OS module to join two directories together, the images directory and then the file name itself. So for the first one, it should be something like this part here, this os.path.join should render to something like ./imgs/ maybe first, assuming it's the first file that it will read, so it will render to something like this. So we are joining imgs with the file name. That is what we are doing there. So now when I print SRC files, I see that we have two Rasterio objects here in read mode, and their names are here nicely like that. I really sometimes don't understand why it doesn't, this os.list there doesn't sort its output alphabetically. But this one doesn't really matter. So now that you have these source files, what I can do is to, you know that we will always need a metadata when we are creating a raster. So let me now say that out meta or metadata, that should be equal to, now we have to access SRC files. You have to access maybe the first one or the second, it doesn't matter. They all have the same width. They don't have the same width and height. It was intentional that I made the shape somehow. But for the other stuff, like the other things apart from shape and the transformation, the other ones should be the same. So let's just access it, then we'll modify this metadata dictionary to properly save the mosaic. So I can say that one dot meta dot copy. And then here I can say that, okay, before I actually even modify it, I need a transformation from the merge, because the new transformation will be given by the merge function. So I need that new transformation. So let me merge it before. So what I can do is to say, maybe mosaic, this name is a variable name. You can choose any name that you want. And then maybe out transform, which is the new transformation, affine transformation matrix that will be generated from the merge. And then I can say that one equal to merge. This merge that we imported from Rasterio up here. Usually I like to import them as other things, but I think I will keep this one as it is. Usually you see me doing something like as rmerge, so that I don't confuse the name with any variable name that I have in my code. Maybe I should make it like that. R_merge, something like that. Let me run that cell again. Then this place will be R_merge. I just do that just to be safe. You don't have to. You don't really have to do that. And then in here, all that I have to pass in is the files that I want to merge. So in our case, that is our SRC files. Okay. Now this is done. And so now we can update our metadata with the transformation that comes from this place and the new width and height that will be generated from the image. You saw that there was a significant difference in the width and height. Even if it's insignificant, that means just about 1 pixel. Rasterio will not spare you. You just have to be very, very exact with whatever you are typing in there. And so I can now say that metadata dot update. And then here I don't know the driver. Maybe let me just, maybe it is GTIF, but let me still put it there. Be GTIF. Please check the spelling. G and T are capitalized. And then the new transform that I want to save the file with, the new affine transformation matrix, that should be out transform. And the new width, or if we should start with the height, the new height, did I get the spelling of height correct? I think so. And then that will be the mosaic that will be created. Let me finish this line, then we'll go and inspect the output of the merge function. And then we pick the first one here. Out trans. Oh, okay, I made a typo here. So if I put my cursor on this rmerge, you see that there are a lot of things in there, a lot of things. A lot of things. Take note of this method parameter that says first. I will explain it. That is even the reason I made the overlap in the cropping. So let me just even explain it here before. So, okay. This thing is saying a lot of things. But in the case where there is overlap, how should it do the the merging? Should it take the value from the first raster? Should it take the value from the second raster? Or should it, whatever thing that you want it to do? I think that is what the method gives it. But for now, let's look at this tuple that will be returned. Two elements, DEST, I don't know why they named it that one, which is a NumPy ND array. You know, from the start of the raster tutorials that when we read, everything is a NumPy array. The only thing that makes it a raster is the geospatial part of it, the affine transformation that helps us put it in a geographic space. And then it will also return the out affine transformation, which is the out transform. This one should have been, I think, on the next line. So it returns the array and the output transform. Okay. That is why we are assessing two things from here, because it returns two things: the array, which is the one we are naming mosaic, and the out transform, which we are the transformation which we are naming out transform. Okay. Once again, if you have any question, you can put in the chat. I monitor the studio as well, so I'll get to it. And then the next one that we will modify is the width. I think that should be the last thing for us to modify. That should be from the mosaic itself. And then we access the shape. Because it's a NumPy array, we can easily get the shape. And then we get the number 2 from there. And then finally, we can save our mosaic. So we can save with real dots. Okay, what I'll do first is to create a file name for the output file. And so I would have done it manually, but let me do it in code and say that output, the output directory, that should be called to ./output. And then you can see that it's not in there. It's not part of the folders that are in there. The last time I showed you how to create this thing with os.make this, and then I pass in output there, and then I'll say that exist okay true, because I don't know how many times I'll run this, so that if it exists already, it will not throw an error. And then now I can say that merged file, that should be equal. You don't have to do this that I'm doing. You can just type in the file name at once, just create the folder manually, make sure that it is there. But I like to do things with code. So os.path.join. I'll now join the output there with a name like merged.tif. Okay, and then now I can use Rasterio to write this file. So I can say with real.open. Now to open merged file, don't forget to put it in write mode, and then we spread the metadata. Okay, and then we can say we want to create it as DST, and then in here all that you have to do to say DST.write, and then want to write mosaic. Okay, so let's cross our fingers. Let's hope that we did everything right, and then run this particular cell. Okay, this error is from proj. I don't know what is happening here, but let's go to QGIS and see if our merge was actually even successful. Or let me first inspect it here. Or we can use can just read it in here and then plot it and see. So let me just do that here before. So that'll be with real.open, and then we can say merge file as src. I can say bound here equal to src.read. I want to read the first band, and let me import the show function from Rasterio. I need it, so that will be from Rasterio.plot I want to import the show. Usually I will import it as our show also, but this one I will leave it like that. So show, and I want to show band. So let me run this and see. Okay, so you see that now the two files have been merged together. And it's a single file. And we can verify that if we come to QGIS, output, and then merge.tif. It's even just one file. It's just one file. And so, yes, that is how to create mosaics. You just make sure that you read them all into a single SRC like this. There are other ways to do it, but I always want to make it simple, the simplest for you. So all that you have to do is to probably declare the path to where the files that you want to merge are. Before you merge, make sure that they are all in the same coordinate system. It's very important. And then you can check their coordinate systems. This is how I choose to read it. To get all the files in there that end with TIFF. If you are using .img files or other raster formats, make sure that you modify this place of the code as such. And then this place, I read them all into Rasterio objects using that line. So I'm joining the images directory with the file. You saw from the beginning how the file, when I printed these files, what it showed us. And then I copy the metadata from one of the files because you know that anytime you have to save a raster, we need the metadata to save the raster. And here is where all the magic happens. This arrow merge, which we imported from Rasterio, returns two things. And so it returns the NumPy array, which will be the grid of values that we eventually save. And it also returns the affine transformation. So we get the two, and then we rename our grid or our array mosaic. So when we get that, we have to now update the metadata that will be used to write the new raster file. Specifically the transformation, the driver, fine. You can change it if you want to, but I prefer the TIFF. And then the transformation to the new transformation, the height to the new height, the width to the new width. Then here you just save the file with Rasterio. This place is just some format through some style I used to write my code. So you can just pass the file name once and it will also work for you. Now, as I wanted to show you something, there is this method here. By default, it is first. I don't know whether they passed the other default values in here, but they should have. They should have. Okay. So that means that if it is merging, creating the mosaic, one of them overlapped, as you saw in the image. If I bring them here, IMGS, I think this should be the second. You see the second one, it's overlapped the first one. And so if I check it off, okay, it will not really make any difference. But you saw in the beginning that it overlapped the first one. So that method says that, okay, in case there's an overlap, how do I treat that overlap portion? Should I use the value from the first raster, or I should use the value from the second, or I should use maybe the mean? I think there are others that you can specify. Maybe we can do a quick search on the internet for the possible values. So Rasterio merge. And then here, the first one from the documentation. I think this one too from. Okay, really, let's check the documentation. Okay, this is one of the times that the documentation may not really be very, very helpful here. So we have all the stuff. The first is here. I'm just hoping that it will give us a list of possible values. Okay, so they are here. Is that first? But the presentation here, I think they can do better. Maybe italicize this default value. So there's the first, there's last, there's the minimum, there is maximum. Okay, there's no mean or something like that. No problem. So those are the possible values you can pass there. So if the rasters are maybe like 5 that you are mosaicing, and there's an overlap for all the 5, an overlap region for all the 5, how should you treat that place? So it's either it uses the maximum, the minimum, the first, or the last. Okay. So that is it for merging. Let us continue with today's the second part of today's series, which is to learn how to do the spectral indices. So I think we will not do so much. It's just a matter of some formula. So just get the concepts and then you can apply it to any indices that you want to create. So, okay. Spectral indices. Okay. Now this is where our LC9 folder will come into play. This one here. And so you can see that the file names, let me print all of them in there. So let me just copy the whole path and then go print os.list directory and finally pass in the whole directory like that. I just want you to see whatever is in there. Okay. I wanted to print it like in lines, not what do you call it? Vertically, not horizontally like this. So for I in this, then I can say print I. Have an indent block, error. So we have, of course, this is not the actual band 1. It only came in because we dragged it into QGIS and did something with it. So the bands that will be interested in will be band 1, 2, 3, 4, 5, 6, 7, and maybe 10. Okay. So let's see how we can, but first I want us to rename these files because I don't really like how these names are. So what we do is that we will rename them and then we will now work with them with the simpler names. So let me write a function to quickly do that. And so that should be, to keep this folder safe, what I'll do is, that will mean a lot of folders too, but no problem. I will open it here. And then create a new folder, call it rasters. You don't have to do this, but you can if you want to. I'll select band 2, hold control or command, select band 1, hold control or command band 2, band 3, band 4, band 5, band 6, 7. And then the band 10 is also here. That's a thermal one. We need it, especially when we are calculating, I think, the NDVI also. So we will check out the formula on Esri's website. So what I'll do is to copy these ones and then paste them in the rasters folder. So now I will not touch my LC9 folder. All that I'm interested in is the rasters folder. Great. Okay. So how to simplify the name? I'll put it as a function. So define simplify name, and then, sorry, this should be we pass in a particular name here. And then we can see that the band, which you can also name as file or anything that you deem appropriate. We want to get all the things in there that end with if, because it can be that's okay. Now the names here, this one is not related to Rasterio, what I'm doing currently. This is purely Python logic. Now all of them even have b.tif. So maybe what we can do is to split them on the last underscore and then take the last part. So when we split it on the last underscore, we can now take the last part. So that means return and then that can be item for item in name dot split. We are splitting it on the underscore, and then we will take the last one. But I don't know whether when we are now working with, okay, now that will not happen because we take off it in the next line. And then in item, and then we now access the, sorry, for item in item for item in name dot split underscore. Okay. This place is that. And then what we can do is to access the first value that comes from it. Not the first, the last, sorry. Minus one like this. Minus one. And then here now we can see return, and then we can say band. So let's test our function here and see. So let me just grab one of these long names. And then I will say simplify name and then opacity. Have to print it before. Now I have b1.tif. Okay, so if I try it for maybe b10, it should give me b10.tif. So that is exactly what we are looking for. Okay. But the thing is, it can be that when we start working on the raster file, the .aux files will be created. So let's just be safe and then say return band if band dot ends with, if band dot ends with, and then if it ends with tif, you don't really have to do with this thing that I'm doing here. I'm just trying today to be more inclined to code than to be clicking and renaming. And then else, if it doesn't, if it's not like that, then okay, that should only be the case. That should only be the case. Or maybe else none or something like that. Sure. So that should also work for us. If you run it again, we still have the same output. And then now we need a shape file, an area to crop, because obviously we can't perform it on the whole image. That will, or maybe we should try it on the whole image. That should also not be a problem. Okay. So now what I have to do is to rename all my files in here and then start the analysis. Let me see. I have one comment. You're welcome. The pleasure is mine. Okay. I honestly don't want to perform it on the whole image. So what I'll do is to create a shape file here. inside our SHPs, or we should use one of these. No, they both don't cover the lake. So what I'll do is to bring the band one, any one of them should do. Just try and locate the lake, and I'll create a shape file maybe this big. I need the water and some vegetation around it. So I'll come into my SHPs, a new shape file, and then this one's name will be ROI, short for region of interest, and then it's a polygon, and the CRS is also the same as the raster. So I click OK, and now drag ROI here. Enable editing for it by right clicking and toggle editing. Come to my digitizing toolbar, pick this one up, and then just make sure that I cover the lake a bit. Right click. I was trying to really get this lake to be in the center, but I couldn't. It's okay. Let me save edit, and then remove everything from here. Then let's get back to Visual Studio Code. Okay, so I'll bring in another function to crop all the shape files one by one. We don't have to do them manually, or we don't have to be just running the code one by one for each of them. We can automate everything with a loop. So we have done this thing before, so I will just be typing it straightforward, but I'll be at least speaking side type, so don't worry. So this will be crop raster to shape file. I also want to teach you, if you are doing these things more practically, how you do it. So you'll not be doing it one by one for each file like the simple examples I've been showing. Usually it will be some sort of functions that you call over some sort of files and pass the output to something else and all that. So we have now the input raster, and then we will have also the input shapefile, and then we'll get also the output raster name. Here, we will first read the shapefile. So that will be a geodata frame. That will be GPD. Did we import GeoPandas as GPD? Did we even import it at all? No. Okay, so we have to import GeoPandas. Let me do it in a separate code cell at the top here. So import GeoPandas as GPD. Let me run that one. And this will be gpd.read_file. And the files I want to read is the input shapefile. So this will give me the geodata frame. And then I can now come here and see something like crop image, and then cropped image transform. Transform. That should be equal to, do we have mask imported? No. So that should be from Rasterio dot mask import mask. Let me import it as R mask. That is completely optional. I can import just as the mask. So as R mask, as I import it, but I have to run this cell again. Other than that, to throw an error. So R mask, and then what I pass is in here is the SRC. Okay. I've not read the raster. Everything here should be inside the raster. So sorry about that. I have to say wait. Real.open, and then I open the raster path. So that will be the input raster as SRC before I even read the shapefile. So that should come in first before the shapefile is read. And everything else that we are doing is indented inside that Rasterio, the width block. We want to crop the SRC, which is the raster file, and the shapes that we want to use to do the cropping is the gdf.geometry. And then we have to pass crop. It's got to. I don't really understand why this crop should be true. Like it's false by default. I don't really understand it because that is exactly what this is supposed to do. Anyway, and then we have our out meta, which should be equal to src.meta.copy. So we copy it and modify it for the new one that we create. And then we see here that out meta.update. We update this one with the driver, the transform. Permit me to copy this one from my notes and then bring it here. These ones, we have been seeing them over and over again. We know each one of them, what they are. So the point is not for you to see me type. That is not the point here, but for you to grasp some concepts. So what is happening here is that I want my driver to be geotiff. Please take note of the G and the T, they are capitalized. And then the height will be the height of the new image that will be cropped, the cropped image. And then the width will also be the new one. The transformation will be the transformation that will be returned, the new affine transformating. And I choose to set my no data value as 0. Others put it as negative 9,999, whichever one that you want. So I want it to be 0. Okay. Now, after all of these updates, I can now say with real.open. And then what do I want to open? That is the output raster. And then don't forget that we want to write to it. And also we have to also pass our spread dictionary, so out our metadata, sorry. And then maybe as DST. And here we can now say DST.write. And then we write the crop image. Okay, so that might also look like a lot, but it's not a lot. We have seen this cropping in previous tutorial, where we are opening the raster file, getting and also opening the shape file that we want to use for the cropping. Performing the crop, we know that this one will return a cropped array, that is the NumPy array, and then the transformation, the new transformation, which is the affine transformation, which helps us to position that graded values with just the ordinary NumPy array in a geographic space. So we update the metadata of the raster such that the height will not be the height of the old file that is coming in to be cropped, but to be the height of the new one that has been cropped, and as well as the transformation also in the height. And this no data value, you can set it to be anything, but just make sure that it will not be a value that will conflict with any of the actual values in your raster. So using a value like maybe, depending on the raster you are using, maybe using a value like 0.56 is very, very bad because there can be an actual cell in there with this particular value. So that means that you have to maybe stick to a value like 0 or negative. And let me just even go for negative 9999 because I don't think there's any cell that should have this value. 0 can actually be, maybe in some cases, a valid cell, digital number. And then after that, we save it with this one. So now that this one is done, what I'll do is now to come. Let me run this cell. I don't have any errors. And then what I'll do here is to now say that images. Now let me call this one images folder. I have one at the top there called images there. So the images folder will be this rasters. So that is also /rasters. /rasters. Okay, so, and then maybe I'll go for cropped folder. Today we create a lot of folders. Forgive me. You can give it any proper name. This name, what should I name it? maybe let me call it dataset. I'm getting out of options now. And then let me make this folder because I know it is not there. So os.make this, and then I'll make the cropped folder exist. Okay, set that one to true because I don't know the number of times I'll run this. And then now I can say maybe for image in os.list directory of the images folder. So I want to iterate over all the files in that particular folder. And then you now can say that the input raster coming from this side is os.path.join. We want to join the images folder with the particular image. So remember there are some images in there like the so and so b1.tif. So you loop over each of them and then get the full part, because without the full part we cannot read it and use it for any meaningful analysis. And then here we can see that the output raster, the input is in by the output raster. That means the raster that we are clipping, what should we name it? That one should be also os.path.join. We are joining We are joining the cropped folder with the image that will be cropped. But take note that these images here, these names are so long. I don't want to be typing these names in my tutorial, honestly. So that is why this simplify name function was created. So what I'll do is that instead of passing the image directly, what I'll do is to, for the new one, for the cropping, we need this, however long the image is to do the cropping. But when you are saving it as a new file, we have that flexibility. So I can call the simplify name and then pass this image to it. So that the new name will be simplified for us. And then now what we can do is to say crop raster to shapefile. And then you may bring this one on a new line. It takes the input raster, which we name the input raster. And then it also takes the what do you call it? Input shapefile. Okay. So we need a path to this input shapefile. So ROI path. Let's set that one to. That should be equal to ./shp/ROI is here. So let me copy path. Okay, so this is the full path. Let me just put the full path in, no problem. And that will be ROI path. And the output raster will be output raster, like that. So to beautify our console, we can just say print. And I usually like to, kind of string, I usually like to give some nice stuff like this, maybe processed. And then what is it that I've processed? So output raster. Okay, so what's happening in this particular code cell? We have the images folder which have all our bands from 1 to 7 and then 10. And then this cropped folder is not there, but it will be created in code by this line. This is the path to our shapefile that we want to use to crop our images, because now if you come to QGIS here and then come inside rasters, if I drop it, you see that is the whole big tile from somewhere in the middle of Ghana, even to the sea. This is the sea, the ocean, the Atlantic Ocean down here. So we just need a small portion up here for analysis so that it will be faster. And so this shapefile here, we have already drawn it. It will crop it. So this one is just looping over all the files and then cropping them. So Hoping that I've not done anything wrong, let me just run this piece of code and see. And something just came in there. Giving no data value is beyond the valid range of the int 16. You let me just put 0. So 0. Run that cell again. And then run this one. So you see that it has processed, just coming in beautifully one by one like that. I think I have a question. Okay, it's just a greeting. Okay, so all of these have been processed. So I see band 1, 2 is here, 3, 4, 5, 6. So we can come to QGIS for faster visualization. Data set is here, and now when I bring band 1, it's not the whole big tile again. It has been cropped for me, the same as band 4 and all the others. Okay, so now let's go into Python and see how we can perform spectral indices on these bands. For that, there's a website here, a web link that goes to Esri's website, ArcGIS Pro. They have the formula there. Let me put it first in the chat, and then when I upload to YouTube too, I'll put it in the comments. So let me put it here as a pinned comment. So you can check the chat. I've pasted it there and I'm pinning it. So if you want to follow along, you can do that. I'll paste the link in there and press go. Okay. So that takes us to the left side. You can see the indices. And then if you click on any of them, let me accept it. If you click on any of them, it will give you the formula here and some explanation. And it's just so great. And even if you have ArcGIS license, you should have access to the ArcPy module inside either ArcGIS Pro or ArcMap. And then if you even want to do that in Python code, the Python code for each of them is here. Okay, so that's just so great. But this ArcPy, you cannot just install it like we are installing GDAL and co. It only comes with ArcGIS. You know, ArcGIS is not open source, so their things are not that free. But this formula, we can use it. So we will not worry ourselves with this bent area index, even though we can do that. Maybe we will, but let's start with the most popular ones first. NDBI, I think that should be normalized difference. Is it building index? Built up index. Maybe you can try that one. But the one that was really on my mind is NDVI. You let me do the NDVI and then NDWI, and then we can try it for the rest. Okay, so this is the formula that we need. Let me copy it and then come to so this is computing NDVI. Let me paste the formula here and then run it. So now we have our rasters folder and then we have our bands stored in there. Let's see how we'll go about with that. So what I would like to do is to read all the bands. So I'll go band 1 equal to, and then I'll say this one, I'll open it with real inline. So real.open, even though I think initially I said that this is not how you should open your files. Permits me to do it this way because if you are doing it with real.open, that will be just a lot of lines of code. So real.open, and then what do I want to open? I want to open /data set, and then there's a file in there. I think we started with the name b1.tif. Okay, and then I'll copy this line of code and duplicate it for all the other ones. So I'll do for b2, b3, b4, b5, b6, b7, and then b10. Okay, so I will change them accordingly. That'll be b2, b3, b4, 5, 6, 7, and then this will be 10. Okay, assuming I did not do anything wrong, I would like to run this particular code. Okay, so everything is correct here. And then what I want to do is to give them their proper name, the proper band names. If we come to Google here and search for Landsat, I downloaded Landsat band configuration like that. This first link that is from usgs.gov will take you to their websites where you can see all the designations for the specific bands. So if I zoom in a bit, as always, you should see that for the Landsat 8 and 9, what I downloaded is Landsat 9, by the way. The band 1 is coastal aerosol, the band 2 is blue, and blah, blah, blah. So I want to use these proper names to rename the bands that we have just imported. Because when you come here like this, it's easier if you have given them proper names, it's easier just to pass them in other than going to refer to your code, which of them corresponds to band 1, which of them corresponds to band 2. But if you know it's offer 2, that is also great. So what I'll do here is another code cell, and then I'll say that the aerosol band, so that if I'm working with aerosol band, I know that I just type in aerosol band, and that refers to band 1. That equals to band 1 dot read. Remember, you have to read the particular band from it. So read the first band was a cell band raster, and I can end it here, but I want to add some modification. We are coming to do some calculation, and I'm sure if you have been following along, you know how strict this raster calculations can be. So I want to, before even I do the analysis, I want to convert all my bands into one data type, just to be sure and safe that there will not be any conflict with the data type, that one is integer 64, one is this, one is that, one is that. So because we'll be doing spectral indices, there will be floats in there. Usually some of these values are between 1 and -1. So that means that there can be floats in there. So it will not be advisable, it will not be appropriate to use an integer data type, or the raster, for the raster to be an integer raster. So it has to be a float raster so that it can precisely capture the phenomena that you want to represent. So what I can do, this is purely a NumPy stuff. I can say .as type, and then the particular type that I want to read it to, I want a float 64. So that means 64-bit float. So I can at least capture like a larger range of numbers. Okay. And then for this one too, I will repeat it for the others. But I don't really have to do it. You don't really have to see me type all of this. That is because I have it in my notes here. So permit me to copy that one too and paste this. This place is okay. Read all bands and convert them to float 64-bit types. Okay. So we have here our aerosol band, which is reading band 1 as float 64, and the rest follows suit like that. So I use the Landsat designation to do that. So this NIR is the near infrared band. This SWIR is the shortwave infrared 1. We have the shortwave infrared 2, and then the band 10 is the thermal band. Okay. So I will run this particular cell. Now I have all of these ones also stored. I can only imagine what our variables space look like. A whole lot of stuff. So I can see we're consuming a lot of memory, but that is not the goal. If you think that your machine is not that powerful to have all this stored in memory, you can restart the kernel, clear all outputs, and make sure that you, when you run a particular cell like that, okay, you cannot really. Then, if your machine is not that strong and it's giving you a problem when you do that, what you can do is to, because I opened this thing into memory, it will still exist. So what you can do is to, just in a new cell, you can be typing something like band 1 dot close, so that you just close all of them and delete them from memory. But I think mine is powerful enough to keep all of them there. And so now that we have all these ones read, what we can do is to now compute our NDVI. So compute NDVI. The formula is at the top here. Actually, this one should be Spectral Indices, because the NDVI is computed way down. I want to paste the formula here as a guide. So I can name my file NDVI and set that equal to, ideally we can just open bracket like this, and then just like this one is done here, open up another bracket to store the NIR minus red. So I can say NIR band minus red, come out of it. So let me expand this so that it will look cleaner to you. Okay, so we have done the first part here, red band. We have done the first part. Now we have to bring a division sign, and then the second part, which is NIR band. Sometimes I rely so much on this IntelliSense plus red band. Okay, and that is how we have to do ideally, and we are okay. So let us run this. We didn't get any error, but we got a warning. We got a warning. It says runtime warning, invalid value encountered in a divide. So there are instances where, because we are doing a division or some form of arithmetic, invalid values will come in. And one of those invalid values is 0. Honestly, we can plot this. Let me see. We can save this. Let's save this. So, okay, let's save it in there. And when we save, we will plot. So the normal stuff, we need a particular metadata. So since our band 1 is still in memory, I've not closed it. Let me copy band 1's meta. So a comment like save generated NDVI, and then this will be meta equal to, let's copy band 1's meta dot copy, and then I want to update it because we have performed an operation here comprising multiple bands. This thing you can skip it, it might work for you, but I want to still update the metadata and tell it that the band count in there is 1. So no matter what the arithmetic brought, I'm only looking for one band, a single band raster. So count here is 1. And then remember the data type that we set at the top there. So we have to override band 1's data type to our float 64 that we set at the top there. So I'll say that D type here is, if you set yours to float 32, make sure that it will be the same. But mine was float 64, so float 64. And this should do it. And so as I like to do, I could say, we don't have a folder to store. This one I will not do it in code. Or I should, maybe. Let me just create it. So what I'll do is to right click here. No, I'll do it in code. We are doing everything in code today. So Spectral Indices in this folder that should be equal to /, in let's call it like that, indices, and then we will create this. So os.make this, and then we call the spectral indices folder. Is this okay? That should be true. And then now our NDVI file, which should be NDVI. Okay, I think I should scroll down here so that the NDVI will show. NDVI file, that should be equal to os.path.join. And I'll join the spectral indices folder with a file called ndvi.tif. Okay, so you can see here that that folder doesn't even exist. It's now about to be created. And then with the normal writing stuff, we can now say with real.open. And then we want to open the NDVI file in write mode. And then don't forget to spread the meta. So meta as dst and then dst dot write. We want to write the NDVI that we have created, and I want to tell it to write it to a single file. Like I still want to specify here that it's a single band raster. Okay, so hopefully we did everything correct. The first part we know is correct. It's only the second part that we need. So our thing has been created. Let me see. Okay, the indices folder is there. So let me come to QGIS for a quick visualization. It's NDVI. And if everything is correct, I think so. The vegetation index, so you don't see my layers, but the color bar here, I think my maximum is 0.46 in the positive, and the minimum is 0.009 in the negative. So all the places usually for this spectral indices, all the places that are have low value, that means 0, I think maybe 0 and below, not always 0, but the lowest values represent the places where the phenomena you are looking for does not exist. So you can see here that the white places are the places, or the places that appear white are the places that have vegetation, and those places that appear darker are not places with vegetation. So for some reason, maybe we are supposed to do some pre-processing, because I don't think there is a vegetation in the lake like that. Maybe there is. It can be. I've not really been to the place, so but you can see that all around it, wherever there is vegetation, there is white, and the water itself is black. So that means our NDVI is correct. But you can change this color scale come into symbology and treat it anyhow you want. Okay, so it worked in my case because I think maybe my crop was fairly perfect. But in some cases, it will not work for you. And especially this particular place. So if I try to separate the code, I should have, but it's not too late. Okay. If I save it again, nothing will happen. This part might worry you sometimes. So we, especially when there are cells in there with a zero value, when your region of interest is not a perfect square, maybe it's a bit circular, very, very irregular, you have some parts of the bounding box, most parts of the bounding box maybe corresponding to no data values. And then if those no data values are set as 0, that means that you'll be doing 0 divisions. And Python will immediately throw an error with a 0 division error. So how we go about that one, in case you are facing something like that, is to still use the NumPy. It still gives us how we can go about it. In that case, you just have to say np.where. I'll explain what this one does. This where will return, will go through the array that you pass, and then return what? Okay. How do I explain this? Have we imported NumPy, by the way? I don't think so. So here, let me import NumPy as np. So np.where. Let me see if I can use the documentation to define it. Okay, so returns elements chosen from XY depending on the condition. Okay, maybe I can use the code I'll type in to explain it. I really understand it, but I don't know how to put it in a very simple term that it will not be so technical. So let me just type this in here and see that because we are using the green. Sorry, which bands are we using? We'll put a comma here. So here you can say this is the NDVI. I put a comma here and put the NDVI code down there. So I can say that wherever the near infrared band plus the red band is equal to 0, I can check if their sum is equal to 0. This dot is also necessary. So if their sum is also equal to 0, then what I want to do is to just put 0 in the array. I know the syntax here might be a bit weird. Sorry. If this near infrared here, if I'm taking the 2 bands, so because you always be performing the operation on 2 bands. Let's say your ROI is irregular, so you have no data values of 0 in most places. So what I'm doing here is that this logic says that before you do NDVI, NumPy, before you do NDVI, check for me if my bands, any particular pixel location, if I sum pixel location in band and the near infrared band and the same pixel location the near and the red band, and my output is 0, this 0 point here. I don't know why I need this one for it to really work, but this is what I did and it worked. Maybe you put the 0 there to work, but it's always okay. It's always good to be safe. So if it is a specific number, just put the number here. If the output of the sum of those 2 pixels is 0, then I should have actually said the sum of those 2 pixels. If the output is 0, then don't bother doing this particular calculation down here. Just put 0 in that pixel location. I don't know if I've explained that part well. So if those 2 values are all 0 and they sum up to 0, don't do any calculation. Don't do this calculation. Just put 0 in there in that pixel position and move on to the next pixel. Other than that, if those two pixels are not zero, then perform this band calculation. So let me remove these dots. And then run this again. I still have this runtime warning. We can get rid of it. But for now, I think, is it numpy error? I think so. So maybe you can say np.set. This set error. Yes, this function here. I think there are a couple of things that we can pass in. Ignore. Let me see if there's an example down here. Okay, so we can pass. You can say that it should ignore all warnings. If you don't want it there, so np.set error, and then all equal to ignore. Now when I run this thing, that warning should not be there. Okay. If I save this same NDVI and then come back to QGIS, refresh my folder, make sure I have the latest file. I don't really see changes here because this is regular. It's fairly regular. But if, for instance, if I had a lake and a bounding box that has so many no data values, then that logic that I showed you there will really save you. This place where you have to check that if it is equal to 0, then put 0 there. If not, perform this operation. Okay. Okay. I'm streaming in 1080p, which is fairly good resolution. So I don't have access to the participant screen, but I'm sure there should be a button there for you to regulate the resolution of your stream. So just click on that button and make sure you choose the maximum resolution possible. Okay. Maybe you can choose 1080 or 720. Maybe in some cases 360p is even very good. Okay. So now this is it. We have computed our NDVI. And this process is not so different from all the others. In fact, if we want to compute, let's just go through the list, deal with maybe 2 or extra 2, and then we can close on it for the day. Another very popular one is NDWI. Okay, so maybe what I'll do is that, like I did for the geocoding, we'll do for other 2. So please, if you're on this website, just check any of them. I will take only the first 2 that drops in the comments. Whichever indices we want us to calculate, just drop it in and then we'll calculate it and then we'll close. I'll take the first 2 in the comments. That is after we do this NDWI. So I'll take the very first 2 in the comments. Thank you. So this is calculating NDWI. We'll paste the formula. And what I'll do is, this one I can copy. Let me just copy because it will not be so different. I don't have to copy the set error, but I'll still be safe enough to write safe code where I'll put the where here. And then let me just also bring in this particular code. And then do some cleaning. So this will be NDWI. And then this one too will be NDWI. This folder already exists, so we will not create it. And then this is NDWI. This one too to NDWI. And then we will write NDWI file. Okay, so is this still the same band one method that we are copying and using? Okay, so all that we have to do is to change the formula here. So that will be green band. This place too should be green band. And then this place green. And then this is the near infrared NIRL band. So I repeat it for all of these places also. So it's just this easy to perform any spectral indices in Python. Just read them like that and then. So assuming I've done all the renaming properly, if I run this, I should have it also created. It's even already there without me refreshing. So let me bring it. And then it's not like the opposite of the NDVI, but this place to wherever there is water, usually that is where the value is highest. And on my color bar, the whites have the highest value and the blacks have the lowest value. So we can see that the water is clearly shown here. So it's white because this is a water body. And you can see that maybe some of these are the ones that feed it, and some other places too that they might be water or wet places on the surface. So that is also that performing NDWI is just so easy like that. So if you have a couple of files in there you want to perform NDWI on it, you can just use a for loop and then you run them over like that. Okay, you can use a different color scheme to also represent this. That is completely fine also. Okay, so let me check the comment section. Oh, I don't have any suggestion in there. Oh, okay. Then let me look for one myself. This is a built-up index. I think so. So that will be this. I was really hoping that maybe if you have a specific in this that binary that you are working on, maybe you would have dropped that one so that we will all look at it. But that was not the case. This is calculating NDBI. This is the formula. So let me copy this one again. So this one should show us the places where they are built up. So anything that man has built. And then this should be, okay, let me change all of them here to NDBI. NDBI. Okay. And the formula here is shortwave. Which of the shortwave infrareds? Let me check. Okay, so one of them, the near infrared, which one is the near infrared? Band 5. Okay, then it means it's using the shortwave infrared one. Okay, so SIWR1. And then this is the, okay, it's the same thing near infrared band. Okay, so this one, all I have to do is to run it, and then we didn't have any error. So I'll remove, okay, let me just uncheck it, and then NDBI. Okay, not the very best, but at least we can see that it is trying to push up some whites wherever the buildings are. This place, like this, looks like a place that should be like a community or something like that. So it's just trying to bring it up as white. But maybe our image needed some processing and enhancement. But we can see that it's still trying to bring it up as the built up places. Okay. Okay. So let's see. Maybe a last one then. We close today. We have done these ones. Which one is SAVI? Okay. I don't really know about that one. So which one is BAI? I want one that the formula is a bit. Okay, so this is bent area index. I don't think any place in that study area is bent, but even though this formula looks a bit weird, it shouldn't be so difficult. So simply because of the way the formula looks like, I'll create one, but honestly, the output will not be what we are expecting because there are no places in that. I'm not sure there are any places there that is bent. Okay. There have not been recent any fires like that there, but I just want to pick one which the formula is it's not so straightforward like the ones we've done. Okay, so that will also be calculating. Let me paste it first. Calculating BAI. Then I'll copy everything in here and then paste it. And then change everything here. That is NDBI to BAI. Okay. And then this particular one, we are using red and near infrared. So I'll just say red band, the near infrared band. And this is the formula that will change a bit. So if you look at it carefully, if I separate it well for you to see, we have to say 1 divided by this whole expression. We open up a big bracket, and inside that bracket, we multiply 0.1. Okay, we are not multiplying, sorry. We subtract red band from 0.1. And then whatever the output of this is, we raise it to the power 2, which we can do in Python with double asterisk 2. And then we now add that one to another bracket, which is 0.06. Subtract the near infrared band, NIR band, from 0.06, and that operation also, you raise it to the power 2. This is the one for the BAI. So that one too is done. Let me come to QGIS. As I said, I know the output of this one will be way off. If you are able to see my legend, my color bar, my layer, say you see that the maximum value rounds up to 0, the minimum value rounds up to 0, because this is not the kind of place to carry out this kind of analysis. It doesn't really work here because the phenomenon we are looking for does not exist anywhere in this space, a bent area. So let me just go to properties here. Information. Check for my minimum value and maximum value. So the minimum is a lot of zeros before 1, 2, and the maximum 2 is a lot of zeros before 7, 6. That may be due to some very places that may look like, but there's no bent area there. I just wanted to show you how to put in complex band indices formulas also. So the link has been pinned in the comments, and I'll put it in the description also on YouTube. And so, as always, let me leave 1 minute if there are questions that I have to address on air. Other than that, we close chapter on today and anticipate for tomorrow. So this is also that one for if you want to find a place that is rich in iron oxide. It's just this particular red over blue, and then that is it. Okay, so it looks like there are no questions. Once again, thank you very much for joining today's stream. It has been a wonderful one as always. So have a great day, all of you who are still in the day, and have a good night. All of you have to retire to bed. Don't forget to keep on practicing. That is what will make you a better Geospatial Python person. So until next time, it is goodbye.